Hi class, let's take a look at problem 9. Now problem 9 are asking if the following functions are inverse and basically to justify the answer. So here we could take several routes. We could basically start with this function, find its inverse, and you end up with this. Or you could evaluate basically the property here. The property here, it's the same as a property that you might have seen, the function composition of f of g of x, which gives you x, and also you could see it as g of f of x. It may be easier to use this property, which is what the theorem says here. But before we actually either use the property, we have to check that they're one-to-one. And I actually provided the sketches of these two here. Both of these functions are one-to-one, which means they pass the horizontal line test. And what this is going to be guaranteed is that its inverse, it's also going to be a one-to-one function. So let me actually start with evaluating f of g of x. Now, what we're expecting on this evaluation is that basically the outcome is x and nothing else. So this actually represents that the second function gets evaluated into the first. So this is an f of g of x, or technically an f of 1 over the values of x plus 1. Oh, there we go. Okay, and this actually means that every value of the x plus 1, it's going to be plugged in into the actual x's. So we're going to be ending up with a function as 1 minus, that's no longer going to be x, it's going to be, well, technically the function g. Let me just write it in green so that it's clear. So in this case, we're going to end up with 1 over x plus 1 and 1 over x plus 1. Now, what we could do here, as we simplify this one, is simply multiply by x plus 1. So this is equivalent of 1 minus 1 over x plus 1 over the values of 1 over x plus 1. So what I'm going to do is I'm going to multiply the top by the quantity of x plus 1 and the bottom by x plus 1. On the good news, when you multiply this at the bottom, well, they cancel out, and on the top we're left with the following. So this is going to be equivalent to and we end up with the quantity of x plus 1 as you multiply times 1 over x plus 1, the x plus 1's cancel, so you end up with minus 1 over the bottom cancels out to 1, which in fact happens to just be x plus 1 minus 1, or the values of x. Now this is what we're expecting. If this one were to give us any value other than technically the x value, then you don't have to continue. At the moment, we're good on f of g of x. We just have to evaluate g of f of x, and if we obtain that the value, the answer is x, then yes, they're inverse functions. So this one is technically done. So let me just say next, and in this case, evaluate g of f of x, and we're punching in now f into g. So this is going to translate to a g of f of x, or a g and f is equal to 1 minus x over the values of x. Now at this point, and let me just erase this mess, this function g, sorry, the function f, meaning the whole function, is going to go as an input. So we're going to just plug it in into 1 over the function and then plus 1 in the denominator. So it is going to look a little bit messy. Our original function g represents technically a simple 1 over, and this is the parentheses and then the plus 1. But instead of the regular x, we're going to be plugging in 1 minus x over x. And then at this point, well, in order to cancel the LCD, we're going to multiply by x and by x. So on the top, we're going to get an x. At the bottom, certain values are going to cancel. So let me just rewrite it. And on the numerator, we're going to end up with an x over, and at the bottom, okay, so we're going to end up with the total value at the bottom of 1 minus x, technically plus x, which actually simplifies to x over 1, or simply the values of x. In this case, we're actually obtaining another single x, and you're multiplying the x times the top, which gives you this x. 1 minus x over x cancels the x, giving you the 1 minus x plus the x. X's cancel, you end up with a 1, and in this case, we end up with a single x. At this point, we can conclude that yes, f of x and g of x are inverse functions, since f of g of x gave us a single x, and this is the same as g of f of x. So you're not supposed to obtain anything else other than a single x. If we ended up with like a 2x at that point, no, they're not inverse functions. That's actually it for this problem.